All right, so for the past few lessons, we have done quite a bit of graphing, right? We found out the roots, we found out the discriminant, okay, with the standard form. So today we'll do some more graphing, but before we start, we have some very uh, interesting thing to observe, okay? So what you see here, it's a table of the x values and the function value with the function of x squared. And now, just to make sure that you know what a parabola is, this is the parabola, and you know this is 0, 0. That's the vertex, okay. And then these are the values with the corresponding x. Well, if you have the x values, then you have the function value, the y value, okay. So the first question is, can you see any pattern, okay, from the table? Okay, can you see any pattern? Now I give you a hint, okay. I'll give you a hint. The hint is, okay, can you look at the relationship between the numbers? Or more specifically, how about you find out the gap, the distance between the numbers? Can you? All right, take a look. Take a look. So between 0 and 1, it's a distance of 1. Between 1 and 4, it's a distance of 3. Between 4 and 9, it's a distance of 5. And without any calculation, I guess the number 7 is already in your head, right? So and between 9 and 16, it is indeed 7 units away. So this is a very, very interesting pattern, okay? That's if we go from the vertex and we go to the right and also to the left, the y values are differed by 1, 3, 5, and 7, okay? So and this particular pattern is going to be very, very impactful in today's lesson, okay? So this 1, 3, 5, 7, and of course, if you want to keep going, okay, you can already guess, okay, the next number will be a plus 9, which is 25, and guess what? 5 squared is indeed 25. So sometimes, you know, math it's a little bit interesting, okay, because some other numbers would appear at some quite unexpected time, okay. So 1, 3, 5, and 7. All right, now, so the next thing that I want to go over is that well, do you still remember the guys right here? All right, so you have the absolute value function. Do you still remember the a, b, c, and d? You know, the a, b, c, d values? All right, now let's go ahead and do a little recap of these a, b, c, d's. All right, so again, a value, it represents the vertical stretch and compression or shrink. Okay, and also if it's negative, okay, if it's negative, that means it's a reflection over reflection over reflection over x-axis. Okay, b, okay, b, it's horizontal stretch. And again, a lot of students, well, not a lot, but some students, they were very weak on this one because this one, it's, yeah, it's challenging. Okay, it's a horizontal stretch or shrink by a factor of, do you still remember by a factor of how many? It's always 1 over b. Okay, and like I said before, if the values here, if it's bigger than 1, okay, if the factor here, it's bigger than 1, it's a stretch. If it's less than 1, it's a shrink. Okay. C and D. C is the C is what? C is the horizontal translation. So we are talking about shifting left to right. Okay. So hope you still remember some examples like x minus 3 means shifting to the right 3 units. Okay. All right, so keep that in mind. And then the D is simply shifting up or down, okay, up or down. So so we talk about absolute value of x plus 4 is to shift up 4 units. Okay. Now, so if you still retain these, wonderful. I've got good news for you. That's nothing new. There is nothing really new for today's lesson because it is about the same thing. Something that could be new is that we're not drawing a V-shaped graph anymore. We are drawing a parabola. Okay, and something that could also be new is the fact that we don't use C and D, but we use H and K, because the H and K, I believe, last year I searched it online. I believe that the reason why they use H and K is because of some historical context. And by that I mean the H actually came from a word from either Latin or something. You can go ahead and search it and find it out. But yeah, so this is called the vertex form because we can tell the vertex from the form. Okay, so we have the root form, we have the standard form, and today we are going to have the vertex form. Now, for the vertex form, I want to say a few things before we start. As I said, it's nothing really new. The A, B, C, D, or now A, B, H, and K, they are practically the same thing. Okay. One thing I do want to emphasize a little bit more is the A value here. The A value here is the same A value that we saw in the root form and also the standard form. They meant the same thing. And so if A is positive, then we have a parabola that's opening up. If A is negative, you can say it's reflected over the x-axis, or you have a parabola that's opening down. Okay, now for today's task, we are going to draw a parabola using the vertex form. Okay, and it will get a lot easier when you get a hang of it. I would promise you it's so darn easy because it's all going to be related to 1, 3, 5, and 7. Okay, so the next video, we will go ahead and start graphing some quadratic equations from the parent functions first, and then we'll do some transformations. It's going to be so much easier if you still retain the stuff that we had in the back in the absolute value unit. Okay, so we'll go ahead and I can click to the next video to begin graphing. Okay.